Hi everyone, may I introduce myself? I'm Themistoklis from ARTEMIS AEROSURVEY. I'm the CEO and founder of this company. It's been a pleasure being here today for this great event. A few words from ARTEMIS AEROSURVEY. We are situated in Athens, Greece, in the Scientific and Technological Park of Athens. We are mostly specialized in spaceborne sensors, generally Earth observation. We're using spaceborne sensors and airborne sensors. We have a remote sensing and digital photogrammetry department. We're combining this information and we use the GIS integrated tools, and in the end we create decision support platform. Our competences, we have invested in a light manned aircraft, specially designed for aerial monitoring. It's a low-cost NASA awarded aircraft, 8 hours endurance, 800 nautical miles of range, using compact sensors for doing remote sensing, and the variety of sensors that we provide. We use RGB cameras for 3D models, very precise 3D models, and change detection procedures. We use hyperspectral sensors for water pollution analysis and geophysics, geology and plant analysis. We also using thermal infrared, and we also collaborating with a company specialized in aerial pollutant sensors. We are doing aerial pollutant measurements. We have already experience in Horizon 2020 funded program named Icarus. In this project, we are doing an aerial campaign in airborne and aerial pollutant measurements and remote sensing. So, thematic area which we are mostly interested. Of course, we are interested in surveillance because we can use our aircraft with 8 hours of endurance. But I would say in the first thematic area, which is Copernicus marine monitoring, I can give you just an example of how we think about that. One problem, for example, it's the issue of oil spills. Our idea is combining the advantages of airplane and drones equipped with hyperspectral and thermal sensors, the analytics procedures, doing also in situ measurements, and using, of course, Copernicus satellite data. The focus and the goal is to integrate data freely available to the scientific and to the related industry community via Copernicus Gateway. It will be a great challenge. And the final goal is to protect the production of reliable marine Earth observation products of enhanced accuracy. Of course, we have some other ideas. It will be a pleasure to explain the other ideas to our potential contributors, corporations. Thank you very much for your time.
So, thank you for this time to present the capabilities of GMB for this tender. In this brief presentation, I will provide to you with some overview about our skills in the security domain, as either maritime or land. So, brief introduction about GMB in what regards the development of added value services by exploiting Earth observation data. So, obviously, we are a service provider, so we are not data provider. As such, we are clearly oriented to what user demands. So, we are skilled on working with different European agencies and also to get requirements and also to do requirement engineering. The solutions are standardized in all the standards that are right now available worldwide, not only OFFSHORE but also Inspire and A.C.S, as commented in the morning talk of Guardia Civil. And also we are innovators in what regards to technology. So we are not only focused to what is added value service, but also to exploitation platform. Experience in what regards the EO-based added value services goes from maritime surveillance to agriculture, forestry, and also providing some image photo interpretation for homeland security, as well as land use and cover and emergency response. So our applications, more or less, the idea is to work with intermediate products of the Copernicus services as much as possible, as well as we are skilled in exploiting and processing raw data from the different optical and radar missions. And then we exploit all the information in a kind of advanced user-friendly interfaces that are based in web-based platforms and also light for being exploited in whatever place in the world with very low bandwidth demands in web regard data extraction. Also, research R&D is important for us. This is a continuous improvement in our work thanks to the different projects that we are executing. So, brief overview of our activities worldwide. There are some pending. Also, we have some work in Japan. Also, we are executing right now some pilots in Ghana and other parts of Africa. We are running some projects in Africa regarding food security and within the agriculture domain. So we are working in a global context, but providing solutions for local partners. We think what is security background and what is related to Copernicus services. Right now we are in the operational phase of the support of external actions in partnership with EGIOS. Also, we are providing services to Frontex through SATSEN inland border surveillance. And also, we are providing maritime surveillance to different agencies and also private customers. So, as you can see, we have operational experience in the different thematic areas of the Copernicus security domain. In what regards land border, our main skills regarding photo analysis and image interpretation. We have a very efficient processing chain that provides us with the capability to be able to deliver products in very, very fast time. And some services refers to reference map, coastline monitoring, and frontier monitoring. Some examples of the operational products that we have delivered. For maritime surveillance, we have an operational system that is called Simons, that is being exploited right now by Guardia Civil and other private customers, for instance, in Japan. The service is able to provide real-time processing. It meets EMSA standards in what regards product delivery and accuracy level. The service has a novel ship categorization module that permits categorizing ships by means of analyzing a single SAR image, and also we are able to provide data fusion with the BDS detections extracted from the SAR or optical data. Some snapshots of the tool are provided here. We can deliver an advanced cartographic interface that is called Socrates. And also we can deliver the products via web services. So we have different alternatives for disseminating the products. One example of the ship detection module is working with wavelets. It's able to detect low reflectivity targets and also the small ones. On the right side of the slide in the zoom snapshot, you can see a small ship with low backscattering associated, and this is associated with a Cayuga-like ship, confirmed by Guardia Civil in a former experiment from some years ago. And also the system is able to provide this, can quantify the confidence of the detection in terms of specific parameters associated with the internal processing. Categorization is also another module. According to the distribution of the gray value of the pixels, we can try to estimate a kind of category for the ship. Here we have two examples for an oil tanker, upside and a bull, downside. As you can see, the different radar signature provides us some means of differentiating the different ships that the system can detect. This has been validated by AIS polls, and right now we are able to provide an accuracy of 70% for images or for targets 12 times the nominal image resolution. Yeah, I'm finishing. Last slides. So for the data fusion module, this was developed for EMSA under a specific contract for providing support for the EMD. And some performance indicators, so more or less, processing time is quite important right now. The tool is being parallelized. The idea is to go below 5 minutes for processing a stream up and even a ScanSAR image, and some snapshots of the user interface. An example of the EU external action service that right now we are running for SEND, the operational one. So this is the kind of service of photo interpretation that we can provide as a complement for maritime surveillance. And also just comment this project that we have planned for Guardia Civil, providing this operational system in collaboration with DNR and Italian Coast Guard, where this ship detection system has been installed and is available to Guardia Civil for the exploitation. So, thank you for your time. It's a pleasure.
Hello, good afternoon. Ugo Di Giammatteo, I'm representing here Advanced Computer System from Italy. First of all, a brief description of the company. A.C.S is an integration and software development company founded in 1979. We work mainly on Earth observation. This is our core business. And in particular, we develop Earth observation receiving stations, so acquisition, processing, and dissemination of Earth observation data. Our main customers are typically space agencies such as ESA, EUMETSAT, and other Italian Space Agency and other agencies in Europe and outside. We also are active in data processing and application development, in particular for what concerns geospatial data processing, GIS processing, and so. For what concerns the figures of our company, it is around 8.5 million euros revenues per year, and we currently employ around 70 employees. We have the main site in Rome, but we also have a site in southern Italy, in Matera, and one in Darmstadt in Germany. At the moment, the A.C.S property is 100% from Exprivia, which is an ICT industrial group in Italy. Apart from the competencies in ground segments, we have many user applications, especially in two domains: big data, analytics, and security, which concerns traffic monitoring, data preservation, and big data intelligence and architecture. And we have also advanced image processing, especially on Earth observation data, which concerns environmental monitoring, non-destructive testing, and diagnostic imaging. For what concerns the areas of interest for the specific project that we are here addressing, we are interested in both thematic areas. In the first one, in the Copernicus Marine Monitoring, we can bring system engineering, implementation and deployment of specialized algorithms, and WebGIS and user interfaces. The reference projects that we can mention here are Melodies, an FP7 project in which we developed a system for using and disseminating CMEMS data and processing CMEMS data in historical series. The Everest project, which is ongoing, it is an Horizon 2020 project. We provided also support, engineering support to CNR, to the Italian Research Institute, for MyOcean in FP7. For what concerns the thematic area 2, the Copernicus security, we can provide strong experience in real-time ingestion and management of vessel position data. We currently manage for EMSA 1,700 positions per second of ships worldwide, with some peaks of 5,000 positions per second. And we perform this kind of real-time ingestion and processing for this position data. We can also provide, again, web-based user interface with the display and analysis capability. And here we can refer some projects such as Nereus, AIM-DATE for EMSA, CleanSeaNet for EMSA as well, and NAUS, a research project for ASI, for the Italian Space Agency. And that's all. This is the end of my presentation. Thank you very much.
Good afternoon, everyone. So again, good afternoon, everyone. I'm here to explain a little bit the core of LUXSPACE, our work. We are a very small company of 52 employees from 12 different nations, which makes the working environment quite vivid, let's call it like that. We are located in Luxembourg, and we are a daughter of OHB. We are a microsatellite system integrator, and we build small satellites, and in our heritage, we build satellites also for satellite AIS services. Apart from that, we also do quality control for Earth observation data, for example, for the LUCAS project of Eurostat, the European Statistics Project. And we provide terrestrial and satellite AIS services and added value services. And we've also been to the moon, but that's just a fun fact. Our competences are that we host an AIS data center, which is also monitored 24/7, and we receive about 19 million position reports every day from about 160 to 190 vessels. It's varying. Our archive of terrestrial and satellite AIS data goes back to 2012, and based on that, we developed quite some services and added value services to use. So, for example, we developed an algorithm and also backend and front ends for a project called Simore, the System for Intelligent Maritime Monitoring, which was funded by the European Defense Agency. And we also support fishing activity monitoring, in particular IUU fishing activities, based on our algorithms. This is a list of contributions to projects in surveillance and security area, and maybe the most prominent one, we are the satellite AIS supplier for EMSA's Safe Seanet, for example. And in the past, we've also supported the European Fishery Control Agency with our data. Our contributions to environmental monitoring and vessel activities are also quite various. I just point out here two. Our project funded by ESA, Transparency, together with the WWF, and together with Drift and Noise. They are also here today. I can introduce you to Panagiotis later if you want. We provide also for the Moser project AIS data for 2 vessels that Drift and Noise is integrating in the project. Our areas of interest for this tender are both in the SAT ocean services and the SAT surveillance services. I highlighted here the areas where LUXSPACE could participate and contribute with its knowledge. The first would be the regular monitoring of marine protected areas. We combine our AIS data, do algorithms, also if needed in cooperation, we really like to share our knowledge. We're interested in that. And the same goes for the Arctic-based services. With regards to the second one, the SAT surveillance services, I would like to introduce you comparable our Simore project, which goes into this direction. It is a project based or limited at the moment to the Baltic Sea. And together with the University of Poznan, we've developed a system to detect suspicious vessel behavior. We correlate suspicious vessel behavior also with port activities, and our user is then able to react. Let's call it like that. So, thank you for listening. If you have any kind of questions, I'm here the full day.
Is involved with. So PMO is a small research institute. We used to be government, we're now private, and we have expertise in innovative customer-focused marine and coastal EO science and services. I'm going to talk here about the EO-based water quality monitoring, talking a bit about harmful algal blooms, work we're doing in monitoring of fisheries, fish farms and natural aquaculture. Also a little bit about the monitoring of marine protected areas for policy and regulation, and a bit about data visualization and integration. So the data that we provide go from the global scale as leader of the ESA Ocean Colour Climate Change Initiative. We also do regional scale processing of data for example, the Copernicus Marine Service in the North Atlantic and Arctic, areas such as this. We also do processing in the Mediterranean. This is an example of yesterday's SST around the coast of Greece. And also much more regional, local scale, for example, using Sentinel-3 at 300 metre and Sentinel-2 down to 10 to 60 metres. This is an example of monitoring for dumping of dredged material off Plymouth. We were using this to see whether the dredging company actually dumped in the right place, as you can see on that little patch there. In terms of data visualization, integration and analysis, we use this tool which is used across a number of our data products. This here shows the Ocean Colour CCI dataset released this year. So within this portal, which is based on Open Geospatial Consortium compliant WXS standards, in other words open standards, you have a whole range of different products like chlorophyll and attenuation coefficients, fire production, things like that. And it's already been used for training, for example, for DGRM, not DGPM, but DGRM here in Portugal. So the kind of things you can do, this is taking a user-selected area where this is drawn by hand, just south of the Azores. Click on that, and you can then extract a time series. So this is an example of where the processing is actually done on our servers, and then the data just downloaded. Let's talk a little bit about some of the other projects we have going. One of these is an ESA Alcntara project. This is looking at Earth observation data for sustainable fisheries management of West Africa. This essentially is to try and reduce illegal, unlicensed and unreported fishing. So here what we've done is used automated detection of fishing vessels from Sentinel-1 SAR and other SAR sensors, together with IAS data. And these data also appear in the portal I showed earlier, with, in this case, the unidentified vessel shown in red in the visualization system. Another area is on harmful algal bloom monitoring. This is going from data, ocean colour, to information. So the image on the left shows a risk map of red, there is a problem, green, there isn't a problem, blue, there is no blue. And time series of this are used operationally at the moment to support the Scottish salmon producers in Scotland, north of the United Kingdom. Another area we're working on is quite a large project in Malaysia, oil spill monitoring, part of a €10 million project. As an example, there was a rather tragic accident back in June. The MT Putri had a fire and then sank with, we believe, the loss of 6 lives. And this was carrying crude oil. So our system automatically detected the oil spill in the SAR imagery. And this is linked together with an oil spill dispersion and forward modelling system. So we can see where the oil actually reaches on land. Since here there's a number of quite important areas of scientific interest and mangroves. So bringing all this together, how can we use these different tools, for example, for monitoring MPAs? Well, to start with, you can use Earth observation to actually define where the MPA is to start with. Here's an example of using the frequency of fronts, which are related to marine mammals. They tend to congregate along fronts. This can inform upon where you should have MPAs to start with. You can then use operational monitoring to monitor physical and biological change. This is biotic, abiotic changes, so in this case, harmful algal blooms. You can use Earth observations from our near real-time service to actually guide in situ monitoring in MPAs of things like gliders and ships and such like. And then you can also monitor infringement and pollution events, such as shown before, the illegal fishing, or actually use SARL to detect directly aquaculture cages or to detect oil spills. This is a way of bringing all these things together in the visualization portal. So, thank you very much.
So, good afternoon. Thank you very much for this opportunity. First, to briefly thank the organization for this very useful event about this. So, let me start by a brief presentation of EDISOFT, and then I will focus on our observation skills. Just to say that EDISOFT is a Portuguese company, belongs to a Soulos group, and our activities are spread through three main areas of activities: naval platforms, air systems, mainly work on air traffic management, and also on space systems. So for this presentation, I will focus on our space capabilities, where our main areas are ground segment services and Earth observation, and in particular, SAR imagery. So this is a picture of the Santa Maria ground station. It's a ground station located in Açores that is managed by EDISOFT, and with this station we were able to set up an operational chain to provide Earth observation services that we are providing to EMSA since 2008. So currently the station has the ability to receive Sentinel-1 data and RadarSat-2 data. EDISOFT has signed an agreement with ESA to manage Copernicus data, so that Santa Maria Station is a Copernicus collaborative station. So it's one of the receiving stations of Sentinel-1 data. As you see, it's a very interesting infrastructure for the purpose of marine I/O, since it encompasses in this visibility area one of the target areas of interest, which is the Atlantic Ocean. With this capability, as I mentioned, we were able to be one of EMSA 4 clean CNET suppliers. So there are 4 companies currently supplying oil spill and vessel detection services to EMSA. This is a daily operation with, I think it was mentioned here, with a very hard timeliness requirements. So the processing has to be done in near real time. We have to deliver the full set of products within 20 minutes of satellite acquisition. I put here, just for your illustration, a case that happened actually in the Canaries, of a fishing vessel that sank in the area close to the Canary Islands, and then EMSA asked us to monitor the leakage of fuel from this tank. This is actually an image taken 2 days after the ship has sunk in the Canaries. So with this is an illustration of our operational capabilities. I have here some additional services that have been developed, like fisheries monitoring, where we take, as I think it was already also mentioned here, we take advantage of the cooperative surveillance means like AIS to correlate with the passive information from the satellite imagery, and from that to correlate to identify positions of the ship if they are currently complying with what they declare to the fisheries authorities. And this is an example of also a ship that was cross-related with AIS. Then through a number of R&D projects, we have been, let's say, developing additional services. This is still a pre-operational service which is based on wake detection for detection of fast boats. This was actually a trial of the system with a fast boat from a Portuguese authority. That this was in the scope of an R&D activity where it enabled us to validate this service. Also, recent activity indirectly related with Earth observation. It was a route compliance monitoring. So the idea was really with AIS again, and also satellite imagery to monitor the route compliance of ships. This was for an Italian authority. And so in a nutshell, I think I can say that we have operational experience. We can work at different levels of the value chain within a service, from data acquisition to processing to correlation of different data sources. And I think it's my final slide. Thank you.
Hello. Yeah. So yes, I'm Kris Lemmens from Offshore Navigation Limited. Our company is actually part of a consortium. We are all maritime service providers. We are driven to provide solutions to real end-user maritime challenges. So we really strive to satisfy the needs of real commercial needs. So who are we? We are a combination of technical incubators or technology incubators and technology providers. On the one hand, we have global maritime services specialized in maritime and oceanic data mining and processing, and R&D services. There is offshore monitoring, which uses this data to develop operational and commercial services. Then we have the technology providers. For example, there's LADAR Limited, who helps us with real-time surveillance of the ocean and subsurface layers. And then, of course, offshore navigation, who has developed a space-based or an EO-based navigation software for commercial shipping. So what do we do? So we transfer, let's say, traditionally non-maritime technologies into the maritime domain. This can mean, on the one hand, that we use existing solutions to, in an innovative way. For example, we are combining EO data from satellites with in situ data, EO data, to provide ship navigation. But if observations are lacking, we develop our own solution and our own observation system, where we have LADAR technology for ocean subsurface detection, currents, waves, and wind, or also a network radar with a very high resolution and short to medium range detection of objects, and also currents, wave, and wind observation. So with all this data, we are also working with data fusion, and and we are providing services in sensor health monitoring. And then lastly, because we're working a lot with EO data, we also provide training, remote sensing, and earth observation and certification programs. So through the years, we developed expertise in 4 domains that has grown out of several development projects. First expertise domain is the maritime navigation, where we have an operational service for energy efficient and optimized ship routing. This has been developed through many EU-funded projects. And very important here is that we use a lot of Copernicus data, if possible. And where we lack data, we use the radar system. We also develop. Then in maritime security, we also have an operational service there for the protection of infrastructure of high value and high value assets. These were mostly privately funded projects. For example, there's Sepulveda, which was actually an EU. Then in the department of sensor technology, like I said, we use this to fill in gaps where Copernicus is maybe lacking or other satellite providers are not providing the data we need. We have developed a LADAR, or laser radar sensor technology, which is also capable of detecting fish, fishing schools or fishing grounds. Then there is the network radar sensor technology. We have also a complete multi-sensor observation system where we not only use satellite and the LADAR, but we also integrate infrared and other types of sensors. Then there is the Maritime Climate Services, where we have a project going on with the ECMWF. We are developing services for the Copernicus Climate Change Service, which will help in, let's say, longer-term maritime planning and navigation. And again, because of all of these domains, we provide training in Earth observation data use. And when we come to the thematic areas, we think we can provide services for both areas. Thematic area 1, we feel we can provide our navigation technology, as we are working there with the Arctic navigation and sea ice detection. That's one of the requirements. There is the LADAR sensor technology that is very well adapted to observing the ocean layer, for wind and for ocean, for waves, also meteorological, so for wind. And again, the network radar technology, also for observations. Climate change, this can be applied to the thematic area 1. And then for thematic area 2, Copernicus security, we have our sectronic system, which is indeed operationally used and specifically developed for increasing the security of critical maritime infrastructures. And it can be further adapted to fit the needs of this thematic area. And yeah, these are the contact details of our consortium partners. We have project websites also listed.
Hello everyone. My name is Dimitris Sikas and I'm project manager and Earth observation expert at Plantec Hellas. In Plantec we have 5 domains of activities: Earth observation applications for environment and security, onboard payload data processing, space astronomy data exploration, spatial data infrastructure, and satellite ground segment. Just some key numbers. We are a group of companies, 4 companies in total, 3 in Italy, 1 in Greece, approximately 55 people at 6 million turnover per year. We are, at Plantec Hellas, we are formal suppliers of ESA since 2006. We are board members of the Hellenic Space Association, the Space Cluster, and the European Space SMEs. Also, from last week, we were nominated as the Company of the Year from EARST, the Earth Observation Company of the Year. Our philosophy is to start from R&D projects and pilot solutions and develop our capacity in order to reach tested solutions and operational projects. Some activities related to Lot 1, the Marine Environmental Monitoring. Starting from 2006, we had several ESA contracts regarding provision of online platforms for ozone data using an algorithm from our sister company GeoK. We're also part of MarkHost to provide water quality products for Greece and Italy. Also, another is a contract was C1s, which was a service we developed a service to detect and monitor harmful algal blooms in the Gulf region, and also provide very high resolution water quality maps. Also continuing this capacity building, we were part of PARC project to map and help the management of Posidonia protected areas. And continuing, we also created an integrated monitoring system for seagrass. From the FP experience, we were part of the BioSource consortium to provide high-resolution land cover maps for change detection for Natura areas. Also, we were coordinators of Ithaca, and together with our 11 partners, we created the system to monitor and identify ancient submerged settlements and shipwrecks. And of course, all this needs to be done under a very good knowledge of SDI, of spatial data infrastructure. So for this, JRC, under the NV Plus project, awarded us to create the Central European portal for inspired data. Okay. Now, these days, together with ACRI, we're in a project called the OSAI, or Neptune, depending on the perspective. And the point is to exploit Copernicus data to deploy local hydraulic models for France and Greece, gather existing solutions, tools, in order to provide services needed for aquaculture stakeholders and maximize the user uptake. Of course, for this kind of service, we try to maximize our capacity to use Sentinel data. Now, regarding to the second lot, the security, we were part of the GMS pre-operational security services for supporting the EU external actions. And also we're part of ACRITAS, which was for land and water border surveillance. Now, after the project period, we say we have also the tested solution now and the operational project. About a month ago, we were awarded from SATSEN to support them to the Frontex border surveillance using high-resolution Earth observation. From the European Environmental Agency awarded us a contract to deliver to them high-resolution layers for forest types and imperviousness for 11 different countries. And yes. The Regional Water Directorate of Epirus awarded us a contract to monitor the eutrophication in the region so they can also be compliant with local legislation. The Decentralized Administration of Western Greece nominated as an award to have an integrated information system for wildfire risk prevention. Now, all of these knowledge, technologies, and these things are bind together under REDCUS. REDCUS is the Geospatial as a Service platform that we use in Planetech. It is a cloud-based service. It uses satellite data and open data that are continuously updated in order to create indicators, maps, and reports. And of course, it's all under a subscription-based pricing. Currently, we have 4 operational primary domains. So the first domain is displacement, to monitor landslides and infrastructure stability in the millimeter level. In the marine domain, which is more of the context here, for water quality monitoring, fishing areas, and algal blooms. And for the land part, land cover mapping, wildfire monitoring, legal crops, and sea soiling, and finally the urban dynamics, urban change, and infrastructure building. And that's all.
So good afternoon, I'm Panagiotis Kountouris and representing Drift Noise Polar Services. In the very next few minutes, I will try to give you an overview of who we are, what we do, and what we can provide to the project. So drift and noise is merging basically polar research, remote sensing, geophysics, and software engineering that we can provide solutions to the polar market, to the marine polar market. This slide presents the backbone of the company. We serve a wide range of users, including institutions, researchers, and touristic and shipping companies. So the users, they can place orders on satellite imagery, model forecasts, and higher level satellite products, which we then processing, and we're giving back the products to the users optimized in a way that they can be transferred in areas with low bandwidth, which is the case actually for the polar regions. Drift and noise had gained some experience through nationally funded projects like MARSAT and business cooperation, which I have also the example with LUXSPACE that made previously the presentation by Simone. LUXSPACE is a company that provides us with global AIS data, and we can assimilate to our systems and then assist ships that they are traveling through polar regions with operational ice maps. An example of this fusion, when we integrate this global AIS data to our data fusion, you can see here in the next slide, where the showcase is for Polarstern Icebreaker, a research vessel, where we assist with SAR imagery and sea ice concentration with a dynamic region which follows always the ship position for its Arctic expedition. Among the others, the services that we can provide but are not limited to, it's on the maritime safety navigation, site monitoring, and current sea ice state. It's worth to mention that it's fully operational. We deliver products in near real time, which means for the Sentinel-1 products, we have a less than 2 hours delay since the satellite acquisition and less than 60 minutes delay for the sea ice concentration. With respect to the Marine EO project, we are interested in the first thematic area, and especially for the Arctic-based services. The way we have envisioned our contribution is that an iceberg ship detection module can be built upon our current infrastructure. First, a review has to be done with the existing approaches and select the appropriate one given the spatial resolution of the product that is going to be used. And then after the implementation to our processing sims and the integration with the AIS data, some performance tests can and should be done, and we would propose by iceberg observations, for example, on site from ship. Finally, the vectorized products, they would contain object types and sizes, object trajectories, and if possible, forecasting some pathways. With the second thematic area, drift and noise could contribute by providing near real-time satellite data over static and dynamic objects, and provide also the infrastructure and the front end for an easy order management. And with that, I would like to thank you.
Good afternoon. I'm Arnaud Durand from European Space Imaging. And thank you for giving us the opportunity to introduce our company today. We are providing direct access to the digital globe constellation thanks to our ground station located near Munich. Our ground stations allow a direct tasking of the satellites of the digital globe constellation, including a last-minute orders, a fast production, and a near real-time delivery of the images. We are providing an access to the leading satellite constellation. It means that we are providing our customers with the largest fleet of PHR satellites, which is composed of GeoEye-1 and the 4th WorldView satellites. And we are delivering the highest resolution, spatial resolution available on the market with images up to 31 centimeters per pixel. Also providing our customer with the highest spectral resolution of PHR satellites, 8 bands on Worldview 2 and Worldview 3, plus 8 extra SWIR bands on the Worldview 3. We are also able to deliver images in archive, including QuickBird and Iconos, which have been decommissioned. And our archive contains more than 5 billion square kilometers of imagery. And this archive is growing by more than 3 million square kilometers of imagery every day. We are serving our customer in a various range of thematic domains, and including the maritime industry. We have, amongst other two major projects in the domain. One is the provision to EMSA of PHR imagery and in near real time, not only imagery but also added value like boat detection, activity detection, change detection, and this added value is performed by our partner DLR, the German Space Agency. And we are delivering about 80 images per month with a rate of success close to 100%. And the end users we are requesting the service to EMSA are requesting our images because their needs can be fulfilled with coarser imagery. For example, for precise visual identification or precise change detection, activity detection along the coast for drug smuggling, human smuggling, and so on. Our second project, which have been shortly presented previously, the Moser project, which aims to operationalize and implement Earth observation derived services for the maritime industry, including shipping, offshore industry, port management, and so on. And we are providing our expertise, our knowledge in satellite tasking in that domain. And to finish, some images captured by our satellites. Here, this is an image over the port of Lisbon, the terminal container of Alcntara, acquired by Worldview 2. This is an image captured by Worldview 4, the latest satellite of the constellation. This is an image with a spatial resolution at 31 centimeters per pixel over Mallorca. This is an image of a Faroe surrounded by the wetlands. An image over Corfu in Greece. And an image over the Costa Concordia in Italy. So this last slide to thank you for your attention. If you have any question about our products and services and possible collaboration, don't hesitate to reach me after the presentation. Thank you very much.
Hello, good afternoon. So thank you for the organization for the opportunity to introduce ourselves. We are a research center managed by a non-profit foundation called FADA. This is some of the entities that are part of the Board of Trustees, and we manage two centers. One is a research center located in Seville, and the second one is a UAV test center in Jaén, Atlas. Just maybe some of you they don't know about us because we are quite new in Earth observation, but just to give you a quick overview, CATEC, the research center, is divided in 3 technological divisions. Two of them, automation, robotics, and material and processes, are more related to the classical aeronautical industry, fabrication in Spain, and then I lead in the avionics and system department. We have a strong expertise in UAVs and also in sensor processing. Also, we manage in Atlas, in Jaén, is mid-south Spain, a UAV test center with a segregated airspace of 1,000 kilometers square and excellent condition for UAV operation. So, what we think we can provide in Marine EO as a possible partner is our experience developing solutions using different sensors, multispectral, thermographic, LIDAR. We have plenty of experience more on with UAVs, but we think some of the techniques and also experience with the sensor processing can be applied also to satellite images. We have this developed solution for security, doing real-time tracking and detection of mobile vehicles such as car. We have experience with forest fires. We have a solution already industrialized that we have helped a company to industrialize and is equipped in 15 helicopters in south of Spain, where the system automatically detects the fire and gets some information about it. And also we have performed some software for automatic classifications, such as counting animals and also detecting the posts of the electrical grids. And also we have experience performing accurate 3D mapping with LiDAR. So we think that even though this most of this experience is being developed with other kind of platforms, some of this experience can be used to get new ideas in the satellite part. On the other hand, we think that UAVs, we are one of the leaders in UAVs in Spain, and we are also having an important part or role in Europe as well. Actually, we got some prizes in the last year. And also we think that at the end, Marine EO, what I think the objective is to develop a platform, and this platform maybe it will be useful to be compatible with other kind of information, such as the one acquired by manned aircraft and also UAVs. So we think that also we can provide this expertise on the type of sensor that this vehicle uses and the formats and so on. So at least could be used as an improvement and a grade to be compatible with not just the satellite information, but also information obtained by other means. So just as a conclusions, we are a research center with a large experience in the UAV part and also in the sensor processing. And we are really interested to participate in a consortium. We think we can provide some added value in the algorithms part in order to improve this detection and classification that was mentioned beforehand, and also in order to use the UAV information as upgrading a possible request for quotation or tender. So these are this is my mail. So if anyone is interested, send me an email, and as well I will be around for some time. Thank you very much.
Thanks. Good morning, everyone. My name is not Sylvain Capot. He's Sylvain Capot. My name is Henri Foucault. And thanks to the opportunity to present here our activities. We are coming from Telespazio France. Telespazio France, it's a company with two shareholders, Thales and Leonardo. I think you are aware about Telespazio. And Telespazio France is also the French subsidiary of the group Telespazio, which contains also EDISOFT. We have three fields of expertise in Telespazio. The first one is the main one about satellite operation, with the launching of a satellite and the maintenance in orbital and so on. The second field is communication, satellite communication. And the last one is the observation of the Earth. In the geoinformation field, you can see here we have all the vertical services. With first of the data, of course, we are able to provide some geographical data from satellite, and especially for the Cosmos Skymed satellite, but also from the Sentinel, of course. And we are able to provide also from products in the different field and services, mainly in all about environment, security and defense, and maritime. For the maritime, and as you can see, we are able to provide the different services for addressing the two lots of the Marineo tender. For the maritime observation, we have two services mainly. The first one is a human processing of all the image. We can address these services through a web portal for the different customers. We are able to take an image from a satellite and to process by manual experts and to provide the result in a near real time. The age of the information, it's about between half an hour and 2 hours. It depends of the place where is the customers and the place, of course, where we can take the picture. The second services is the automatic process of the image. We are conducting this process through Sentinel image, of course, but we are also dealing with AIS data to make the correlation by automatical chain and to provide the results in near real time. Our customers are European, of course, through a different H1 2020 project, but also the French administration, like the French Navy, for example, also for the marine protected area of the French agency, and also for the maritime affair, for which we are providing services in the Indian Ocean, including the detection of the ice in the south part of the Indian Ocean.
Concerning the environmental survey, we developed also several services dealing with the ingestion of CMEMS products already in a downscaling process coupled with modeling, numerical modeling and biogeochemical modeling and optical imagery to reach the needs of the collectivity and the nearshore environment. One of the service we are deploying actually is the forecast and the daily warn of the water quality and the optimization of the beach closure to prevent economical and sanitary effects, mainly during touristic and summer events. So we use mainly Sentinel and Copernicus data to provide this water quality information, such as surveying the turbid plumes and the total suspended matter, but also algal blooms and chlorophyll A concentrations. And we also make some regular surveillance and make some warning alerts on the lower part at the right. It's two conditions in the Southeast Asia last spring, where a large pollution, chemical pollution occurred. So we can observe unusual inherent optical properties that have been confirmed to be phenols and hydroxide. So a large chemical pollution that can be surveyed with this kind of tools. And we also provide satellite bathymetric, satellite-derived bathymetry to monitor the coastal habitats and nearshore environments. So this goes for consortium in this tender. So here are our mails. Thank you.
Thank you. Good afternoon to everyone. I'm Jean-Yves Le Bras from CLS. So I'll just present you my company. The organization of CLS, it's first to indicate that we are a company located in several places with main facilities in France. Today we are located in 26 places around the world. And the objective and mission of CLS is to provide services for environment and security. CLS was founded in 1986, so 30 years ago already, with two institutional shareholders, which are the French Space Agency and Ifremer. So I will not say that Marine and EO are part of our DNA, especially because at the beginning CLS was created to operate satellite service, but satellite tracking, so not Earth observation. And Earth observation came at the end, in fact. So it's a point that I would like to indicate. Earth observation takes a lot of value when it is fused with other data, in particular with other satellite data, when it is in the marine field. So, what are we providing currently? Typically satellite tracking data, but also satellite oceanographic products. So this came in the 1990s, in fact. There is a strong group of oceanographers. And Earth observation came later, in particular used for surveillance of illegal activities, and then in the security field. So we are today working essentially with radar data in the marine area, but we are also using high-resolution optical data. As our activities are split into 6 sectors: sustainable management of fisheries, environmental monitoring of the Earth, maritime security, and also for space customers. So these 4 activities are related to marine EO. The 2 other little less. We are also providing marine EO services for the oil and gas industry. So my last slide to come to the point of marine EO. We are then interested in the 2 areas provided by this project. Our strength I would mention for CLS is that we have been developing all these services on the basis of scientific background. So our approach was to go from science to operational services, and we have several facilities which are today used for both maritime services, maritime security, and environmental monitoring services. So we are interested by R&D which are proposed in this project, especially of relevance, those which are related to the strong R&D groups for SAR processing that CLS hosts in a center in Brittany, in Brest, and also for space oceanography. Our approach to R&D is also to find some partnerships, and this can be both for the deployment of services with other technologies, so not only satellite data, but also AirPass, for example. And we are also interested by R&D, in particular, of particular relevance for this project, to exploit new concepts and new platforms. So this is it for CLS presentation. Should you have any questions? Thank you.
Good afternoon. I'm Ana Mendonça, and I'm working in division chemistry, the division of chemistry and pollution, marine pollution of Hydrographic Institute. I'm pleased to be here and have the opportunity to show our contribution to CMEM services and offer the availability jointly with the Marine Research Center a set of high-level processing products that will be useful for marine yield services. The Hydrographic Institute is a Portuguese Navy institution with vocation for marine research and protection. Through the division of chemistry and marine pollution, the EH performs marine monitoring and contributes to marine pollution control. As an example, we are able to do oil spill identification. All our assays are subjected to quality assurance and control with their results validation. Our analytical competencies are certified through the accreditation of 19 of our methods, such as determination of nutrients and temperature in the environmental waters. There are also 32 methods that were submitted to accreditation, namely dissolved oxygen, metals and organic contaminants in marine sediments. The Marine and Environmental Science Center is a research center performing studies in the aquatic systems. The group of laboratories in the University of Lisbon have a large experience in marine phytoplankton studies, including validation of ocean color products, pigment analysis, phytoplankton cultures, and research on remote sensing methods for harmful algal blooms detection. As a result of our work, EH and MAR have been contributed with several in-situ monitoring data, feeding the CMEM service through these projects and networks, ModNet, Correcif, ACWS, and Ocean Color CCI. Combining this data with other Copernic products, we are able to contribute to South Ocean service through remote sensing data validation, development and validation of biogeochemical models in areas faced with climate change scenarios and other pressure scenarios, gathering in situ and remote setting data crucial to develop quality indexes to be used in water framework and marine strategy framework directives reports, ecosystems impact assessment of economic activities such as fish farming, fisheries, and other marine research exploration. We can do also development of eutrophication and harmful algal blooms indexes in key cities for elaboration of marine economic supporting forecast scenarios. Software developers are welcome to work with us and develop these products and validate them. Thank you for your attention.